Well, I bumped my phone and stopped my recording, so now you guys have two videos to watch because I'm not starting over again. Okay, so we're going to keep this part up here so that you can see it as we go along with this graph. And this graph tells us to graph the data. We want to determine the maximum and the minimum, the domain, the range, the intercepts, the increasing and the decreasing intervals. And we're going to do some of these in what we call interval notation. So I'm going to pause the video, and what I'm going to do is I'm going to draw my axes. I'm just going to draw a L, and I'm going to make these ones down here because I need to go my time down here, and I need to get to 120. I think I'm going to make them by fives, and then these ones will just be 1 because my highest is only a 12. So I'm going to pause it. I'm going to do that, and then I'm going to plot the points. So like 0, 4 is a point, 10, 6 is a point. I want you guys to pause it and do the same, okay? Okay, so this is what your guys' graph should look like. I'm going to zoom in just a tiny bit more so that you can see it. I've got them graphed and I have them connected. And I'm going to move this down so we can just kind of keep an eye on it, okay? All right, so now what we're going to do is we're going to follow these directions that are hidden under here. I'm going to find the maximum and the minimum first. Now, when we have a graph like this one has more than one minimum and maximum. And so we know in that case, we're going to be having relatives and absolute minimums and maximums. So I'm going to do my absolute maximum. It's the highest point on my graph. So, and maximum and minimums are always measured in my Y values. So as I look, I see a high point here, which is at 10, but then I see this high point here, which is at 12, and I can see that this is the absolute highest point on my graph. Okay, so my absolute maximum, sorry I didn't leave you guys a whole lot of room, is 12. And all we do is write the value of the Y value of that point. That's all we write. So then that makes this one right here a relative maximum. And that is at 10. Okay. Let me scoot that over a little more. Sorry, that's a little... just got myself all mixed up. I'm going to get rid of that paper. Okay. Hopefully that's a little better. Sorry about that, guys. Okay. So now I also have minimums, and my absolute minimum, so out of room here, absolute minimum is going to be the lowest point on my graph, the very lowest. So I see I have a low here, which comes in, well, as I come across, I can see that I have this one right here, which is even lower. And as I come across, these ones are actually at the same point. So I have two absolute minimums at the same point, and they're both at 4. So we don't write 2 of them, we just write 1 of them. And then this one right here is a relative max or minimum, and it is at, we drag it across, 5. Okay. All right. So now we're done with those. Okay. And then the next thing we're going to find is our domain and our range. Well, our domain is, I'm just going to get rid of this because we just don't need this right now. Okay. It's kind of driving me crazy. Trying to do this at home is a lot harder than at school. Okay, so my domain and range. My domain is all of my X values that belong in this graph. And my range is all of my Y values. Okay, I'm going to show you a little trick to help you out with that. So what I like to do is I like to find the very beginning of the graph, starting from the left-hand side, and draw a line on my x-axis down from it. So right there. And then I go all the way to, if it was to break apart, I would draw another line. But since this one is continuous and doesn't break apart and ends right here, this is the next line that I'm going to create. And then I'm going to take a highlighter and I'm going to highlight those points between those two lines, because that is my domain. Oh, great. It's smearing my marker. Even better. I hate it when that happens. Okay, So this is my domain, this pink part, and we're going to write that in interval notation. I'm going to write it kind of over here because we're running out of room. So I'm going to write my domain. And remember, this number and this number, because they are endpoints, are included in our domain, so we use brackets. So this goes from 0, and it goes all the way to 120, and we close the bracket. Okay, now my range is a little bit different. My range goes on my y values right here, and I'm going to do the same kind of thing. I'm going to go from my lowest point on my graph, which is at 4 right there, and I'm going to go to my highest point on my graph, which is at 12, which is right here, and I'm going to color that in. I'm going to use green this time, and that is my range. Okay, so now all I have to do is write that down, my range in interval notation. And again, these are endpoints, so they're included. So it's from 4 and it goes up to 12. Okay, all right, so we've got our domain and our range done. Let's talk about intercepts. Remember, my y-intercept is where x equals 0, so x equals 0 right here on the y-axis, and my graph at least meets my y-axis right here, so my y-intercept, we put in ordered pair form, is 0, 4. Now my x-intercept is where my y equals 0, or where it crosses my x-axis, and as we can see, this does not cross our x-axis, so there is none of an x-intercept. Okay. Now my increasing and my decreasing values intervals are going to be a little tricky because I have a couple of them. So my graph it increases from the beginning to this point right here. That is increasing. Okay. It also increases from this point right here to this point right here. That's another increasing. So let's talk about increasing first. I'm going to put increasing down here. I know they're kind of all spread out. I'm sorry about not leaving you guys enough room. So at this point of where we start, that one is included. And we use x values for increasing and decreasing. So we're going to go off our x value. So my x value for this one is 0. And it goes to where x equals, remember these go by 5, so this is 30 for me right here. However, because this is a point of change where it goes from increasing to decreasing, the actual point of 30 is neutral. It's not increasing or decreasing, and so it's not included, but we have to use it to tell what our graph increases to. So we use the number 30, but we put a parenthesis around it. And then since we have another section that's increasing, we kind of use this U looking thing that means union, it means together. And this point of change right here where it goes from decreasing to increase is at 60. And again, it's not included, but we have to use the number. So we use a parenthesis. And then it goes up to this point right here, which if I come down is 90. And again, it's another point of change. So because it's a point of change, we don't use it and we put a parenthesis. Okay, now my decreasing, geez, where am I going to write my decreasing at? We'll write decreasing right up here. Okay, my decreasing is happening here to here, so this is a decrease, and from here to here, which is a decrease, stopping here. Okay, so my first interval of decreasing starts at 30, but it's a point of change, so it's not included. And it comes down until we hit 60, again at a point of change, so it's also not included. And then there's another part that starts here at 90, not included because it's a point of change. And then it ends right here at 120, which because it's an endpoint is included, so it gets a bracket. Okay, and that is all of that. Yay! Now what you guys are going to do is you guys are going to pause the video and you're going to do this one all on your own. So all this stuff that you just found for this graph up here, all these domains, these intervals, everything, you're going to find for this graph and write them down over here. Okay, this is about the distance and like how fast we were going. Okay, so pause the video, work on that. If you want to work with somebody next to you and they're ready to work on it, you may do so. Just make sure that you get this done before you start the video back up. But you do need to start the video back up because you're going to come back and do some more problems. Okay. All right, welcome back. So you guys should have done the This part, if you haven't yet, please stop and go do it. And at the end, I will show you what that looks like. Now we're going to do the watch and learns, 3 of them that we have here, and then you'll be on your own and ready to do your own work. Okay, so this first one says graph each set of linear equations on the same set of axes. Name the coordinates of the point where the 2 lines intersect, where they cross, okay? So this first one I'm going to do, just remember these are both linear, so that means that I can use the y equals mx plus b formula. So any number with a variable is going to be my slope, and then the other one is going to be my y-intercept. So in this case, there's no actual number right here in front of x, which means it's 1. Okay, so my slope for this one is equal to 1 over 1, and then my y-intercept is -5. So I'm going to graph this using a t-chart or a t-graph. I think it'll work the best if I do that. Remember, this is my y, this is my x. Okay, so I'm going to start at -5, so I'm going to go down 1, 2, 3, 4, 5 right here. And I'm going to be going up 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1. And then I'm going to connect these. Sorry guys, I'm stuffy, I have allergies. I don't mean to be sniffing in your ear. I'm going to connect these and extend my line out because you never know, my line could cross way down here. So I have to make that line extend the whole graph. Okay, my next one, my y-intercept is 1. I'm going to do this in a different color. My y-intercept is 1. And my x, or my slope, is this -1. That's right here. See this negative? So that means my slope is -1 over 1. So I start at 1, x equals, or my y-intercept equals 1, and then I'm going to go down 1 over 1 every time. So down 1 over 1, down 1 over 1, down 1 over 1. And now you can actually see where they cross because we created both those dots. But I'm still going to line this up and draw the line. Okay, and you can see right here, this is my point of intersection. So now all I'm going to do is I'm going to write it as a point. And this is the point 1, 2, 3, 1, 2. So it's 3 and then down 2, so -2. So that's the point of intersection. Okay, you're going to see down here that this one that you guys have to work on, this first one doesn't have anything except x. So it's like saying +0. Okay, so kind of think about that as being, that'll be your y-intercept, is that +0. Okay. All right, this next one right here says for each graph, state the intervals where it's increasing, decreasing, or constant if it has a maximum or a minimum, and identify the domain and the range. Now, we're going to assume, because this graph got cut off, that these just keep going. Okay? Okay, so the first thing we're going to talk about is the intervals where it's increasing, decreasing, and constant. So as I move left to right, this is an increase right here. So my increasing interval, it goes from infinity. Remember, when we're talking about increasing, we talk about x values, and this just keeps going and going and going and going. That means that this uses every negative infinity number, every negative x value there is. So it's going to start at -infinity, and since it's infinity, we use a bracket or parenthesis. Then it's going to stop right here at this point of change, and that x value right there is actually -2. So then we say -2, and because it's a point of change, we put a parenthesis. Okay, now we have this part right here where it's straight. This is where it's constant. You should remember that. Okay, my constant interval goes from this -2, which because it's a point of change, it's not part of it. And then it goes to where x equals 5, and again, it's a point of change, and so it's not included. Okay, and then we go to decreasing. So my decreasing interval starts at 5, but it's a point of change, so it's not included. And it goes to, it's going to keep going every x positive is going to keep going because this line just keeps going. And even though it's diving way down deep into the negative y's, it's still going to be infinity right here for x. So then it's a positive infinity, and you use a parenthesis. Okay, so that's number 1 answered. Number 2 says, does it have a minimum or a maximum? Well, it has no minimum because remember with minimums and maximums, we look at y values. And the minimums, they just keep going further and further and further down into the negative y's. So there's no minimum. But my maximum is right here where this straight line is, and that is at y equals 2. So my max is at 2. All right, so that's number 2 answered. And now we want to identify the domain and the range. Well, the domain is the set of all x values. And remember, we talked about how this way it keeps going into negative infinity. This way it keeps going into positive infinity. So my domain is, you could write all real numbers, or you can write it in interval notation like this. And sorry, I am horrible at writing infinity signs. It goes from negative infinity to positive infinity. Now my range is a set of all my y values. My highest y value is here at 2. It doesn't go any higher, but then it keeps continuing down into negative infinity. So I'm going to start at my lowest, which is negative infinity. And then my highest is 2, and that point is included, so that one gets a bracket. Okay, now the last one. Oh, and that's all for that one. You'll do the same thing for this down here. It's a little trickier though because it's disjointed. So kind of keep that in mind when you see that, okay? All right, last one right here. It says write the recursive and explicit using the zero term equations for the given table. Now note that this does not have zero terms, so you have to figure it out. Okay, but first, before I can figure that out, I need to figure out what's happening here. Now from 6 to 12, I know that I'm either adding 6 or multiplying by 2. It's got to be one of them. So I'm going to check my next term to see which one it is. So from 12 to 24, that's not adding 6, because if I added 6 to 12, I'd actually get 18. So it's not adding 6. If I multiplied 12 by 2, I would get 24. So this is multiplying by 2. And then 24 times 2 is definitely 48. So this is a geometric sequence or exponential. These are the kind of things you should be able to recognize right away when you see this kind of stuff. Now, the other thing I need to figure out is what's my zero term? Well, if I'm multiplying by 12 every term, to go backwards, I'm going to do the opposite, which is dividing by 2. So if I divide 6 by 2, I get 3. So my zero term is going to be 3. So my recursive for a geometric, it should be pretty simple. And we're using n's here, so it's f of n equals the value of my first term, like that, or value of my previous term, sorry, and then just times 2. But we have to make sure we note that the zero term is equal to 3, because we need a starting point. We need somewhere to start multiplying by 2. It could be any of these, but because it tells us to use a zero term, we use a zero term. So now with the explicit equation, I'm going to use the y equals a times b to the x power to write my explicit. Except that I'm going to put f of n here and n there. Okay, so I have f of n, because I can interchange these with y, equals, and a is my y-intercept, and my y-intercept is where my value is, my n value is equal to 3. So it equals 3 times, b is my ratio, what's happening here, so 2, and then instead of x, because it denotes n right here, I'm just going to put to the n power. Okay, that's using my zero term. Awesome. Okay, so now it's your guys' turn to do these. Make sure that when you come up to get your stuff checked off, you have this one and this one for me so that I can check them off, okay? All right, guys, thanks for watching. Bye.